Hello and welcome. Today we're going to learn how to factor out the GCF from a polynomial. First, let's review what a GCF is. You probably learned about them when you learned how to simplify fractions. If you are already familiar with GCFs in that arithmetic sense, then you can skip ahead using the timestamps. For those of you who are still here, GCF stands for greatest common factor, which means that it is the number of largest magnitude that is a factor of all the numbers in the list. Let's find the GCF of 15 and 40. First, we'll list all the factors of 15, those being 1, 3, 5, and 15. Next, we'll list all the factors of 40, those being 1, 2, 4, 5, 8, 10, 20, and 40. Then, to find the GCF, we go down the list of factors for the number that has less, in this case clearly 15. And we'll start at the top, and 15 we will see is not a factor of 40. So it's out, and then we move to the next one, being 5, which is in fact a factor of 40 right here, and so the GCF of 15 and 40 is 5. Let's do one more example, this time slightly more complicated. 32 and negative 56. Like last time, first we list the factors of 32, those being 1, 2, 4, and 8. Then we list the factors of negative 56. Those being plus or minus 1, 2, 4, 7, 8, 14, 28, and 56. The pluses minuses there because the 56 is negative. Then we start at the list of the factors of 32 because it has less, starting at the top with 8, and we check if it's a factor of negative 56. In this case, positive 8 is. So the GCF of 32 and negative 56 is positive 8. Something that I always want you to do after learning a new method or procedure in math is to ask why. What does it accomplish? And in this case, we find GCFs of integers in order to simplify fractions. Say we had the fraction 15 over 3, and we wanted to simplify it. What we would do is find the GCF of 15 and 3, which is 3. And to simplify it, we would divide the top and bottom by 3 to get 5 over 1, or just 5. Now we're going to look at a use for GCFs that I have dubbed undistributing. Say we have the expression 4 plus 12. If we were to undistribute it, we would attempt to turn it into an equivalent expression with parentheses that could be distributed to get 4 plus 12. There are many ways to do this, but the one we'll focus on involves finding the GCF of 4 and 12, which hopefully you can see is 4. With this information, we're going to divide each term by the GCF, 4, which will get us 1 plus 3. Next, we can set it up so that 1 plus 3 is on the inside of parentheses, and 4 is being distributed to them like this. It is most likely very unclear how this helps us, but what if I were to ask you to do that with an expression like 9 plus 6x? First, we would have to find the GCF of 6 and 9x, which it may not be very clear how to do, but let's take it one step at a time. First, we list the factors of 6, which are 1, 2, 3, and 6. Then we list the factors of 9x, which we should do by treating the 9 and x as separate entities. We can see the factors of 9 are 1, 3, and 9, but the only thing we can say for certain about x is that 1 and x are both factors. This is because x could very well be prime. Then we look at the factors of 9 and x as factors of that term as a whole. We can see that x is not necessarily a factor of 6, so let's assume it isn't. Then 3 would be the GCF because it is the greatest factor we know is in both terms. Now we should express 6 plus 9x as an undistributed expression with 3, the GCF, on the outside of parentheses, and the binomial 2 plus 3x would be on the inside. If we wanted to check our work, we could redistribute the 3 to both terms, and we would indeed get 6 plus 9x out. The expression you see on screen is called the factored form, and the goal of factoring in this unit, which is what we are doing, is to turn polynomials into factored form. Hopefully that all made a little bit of sense, because now we're going to try something slightly more complicated. Let's factor the trinomial 20x squared minus 12x plus 48. While we could list each individual factor, that method will go exponentially more exhausting the larger the polynomials get. Instead, let's first notice that x is not in every term of the polynomial. Therefore, it will not be in the GCF because we can't pull it out of every term. Knowing that, we can just find the GCF of the coefficients and leave the variables intact. Upon doing this, we will find that the GCF is simply 4. Next, we divide each term in the polynomial by 4, which gets us 5x squared minus 3x plus 12. Finally, we put our new trinomial in parentheses, the GCF on the outside, like so, and we are done. Let's do one last example before discussing a more generalized method. To factor 28x cubed minus 35x squared y plus 84x squared, we should immediately notice that one of the variables is in every term, namely x, but the other, y, is not. This means that x is going to be in the GCF, but y will not be. However, every term not only has x, but it's at least x squared in each one. This means that x squared will be in our GCF. So our GCF will be of the form ax squared, where a is an integer. To find a, we will find the GCF of the coefficients, which after the use of the previously stated method, we will find to be 7, meaning the GCF of this polynomial is 7x squared. Lastly, we divide each term by 7x squared, yielding 4x minus 5y plus 12, and put it in parentheses like this. And if we check our work by redistributing 7x squared to each term, we will see that it is indeed equivalent to the original trinomial. You will sometimes encounter polynomials that have a GCF of 1. In this case, there is no point in factoring it the way we have learned, because it doesn't do anything. Recall that any number multiplied or divided by 1 just equals itself. Polynomials like this are called primitive, and if you encounter one, you can simply write that the polynomial is primitive and move on. A few examples of these are on the screen. A generalized version of the procedure to reduce polynomials to factored form goes as follows. 1. If the first variable is in every term, add its lowest exponent version to the GCF. 2. Repeat until you have done every variable. 3. Add the GCF of the coefficients to the main GCF. Note it will sometimes be negative. 4. Divide each term of the polynomial by the GCF you made. 5. Write the results in parentheses and leave the GCF on the outside. And that's it. Let's do some comprehension questions to rehearse your knowledge. Pause to do them on your own. And here are the answers. Thanks for watching. I hope you enjoyed and learned something. See you next time.